A very good morning, children. Hope you understood the last session where we talked about the cardiac cycle and all the different stages in the cardiac cycle. So today we are going to discuss another topic, that is the double circulation and single circulation. So now we will try to see what is single circulation and what is double circulation. Okay, children. So look at the board. Now the blood travels from the heart. The blood travels from the heart and goes to all parts of body. And now what it's taking here? Oxygen. And all parts of the body will receive the carbon dioxide. And if the blood directly comes to the heart. Now that means the blood is coming to the heart only once here, right? The blood is coming to the heart only once. So that's why we call it as a single circulation, because the blood is only traveling once here, right? From the heart, it is only going to the all parts of the body and coming back to the heart. So that's why this heart is called as the single circuit heart, and the circulation is called as the single circuit circulation. Why it is called as single? What is circuit here? It's a cycle. Okay, like a running track. So you just look at the running track. So it's a cycle, right? If you run here, it will end. Okay, it's some particular place. So in the same way, the heart is also sending the blood. Okay, and it is going to all parts of the body and releasing the carbon dioxide, and the same blood is returning back to the heart. It returns to the heart. It comes back to the heart. So that's why we call this as single circulation or single circuit circulation, or the heart is also called as the single circuit heart, because there is only one cycle available here, right? So basically this happened. The best example which you can take is the fishes. The best example which you can take is the fishes. In fishes, now if you take the fishes, the heart will pump the blood to the gills. Okay, children? The heart will pump the blood to the gills, and the gills will receive the oxygenated blood. So now the blood is in the gills, right? So now this blood will be carried to each and every part of the body, and whatever the carbon dioxide which is here in the gills will be exchanged with the oxygen. So now whatever the deoxygenated blood which is here, it again comes to the heart. So how many times did the blood travel from here? It's only once, right? Only once the blood traveled from here, that is heart send the blood to the gills and gills send the blood to body parts, and again the same blood comes to the heart. So it is only one cycle. It's only one cycle. That's why we call this as a single circuit circulation, and this heart is called as the single circuit heart. But whereas now this is not exactly same when you talk about the human body, because in human beings it is double circuit circulation. It is double circuit circulation. So now we'll see what is this double circuit circulation. So now what is double circuit circulation? See, when you talk about the single circuit, that means the blood is coming to the heart only once. When you talk about the double circuit, that means the blood is coming to the heart twice, right? It is making two cycles. Now what are these two cycles? We will see now. Okay, children, now we will see the double circuit circulation in the heart, right? So now this is also an imaginary diagram. So I just have drawn this so that the diagram will not confuse you, because whereas the systemic aorta will go from this side and enters into the each and every part of the body, right? So it goes and turns, it takes a turn like this. So here I have just drawn an imaginary diagram, right? It never starts here. Okay, just remember that this systemic aorta will never start here. So just that's the only thing you just keep in your mind. So now when you come to the double circuit circulation, so remember all the points which I'm going to talk about now. So when you talk about the double circuit circulation, Now there are two types here now. One is the systemic circulation. Second one is pulmonary circulation. Okay, systemic circuit or pulmonary circuit. So here, double circuit heart or double circuit circulation, there are, because it is double, you can find two types, right? One is systemic circulation, second one is pulmonary circulation. Now we'll see what is systemic circulation first. We'll see what is systemic circulation, and also we'll see what is pulmonary circulation. So better we'll go ahead with the pulmonary circulation first. Now coming to the pulmonary circulation. So this all you know, because we have studied this one yesterday itself, but I just want to make sure that you know the circulation and also the circuits also, so that if it comes in the examination, what is systemic circulation, what is double circuit heart, and what is systemic heart, what is pulmonary circuit, so you should be able to answer those questions. So because I just want you to remember these terms, okay, so that you can answer the questions. Now coming to this one, so now we are talking about the pulmonary circuit. So pulmonary circuit is very easy here. Now we will see the pulmonary circuit. So pulmonary circuit starts from the right ventricle, and this right ventricle will have what blood here? Deoxy blood. So now this deoxygenated blood, now as it is having the carbon dioxide in it, okay, and that's the reason why it is called as the deoxy. That means there is no oxygen. Oxygen is not present in it. So now that blood should go to lungs for the purification. So when these ventricles contract, especially the right ventricle contracts, the blood from here will start moving to the lungs, so that it can go to the right lung and also to the left lung, so that the blood will be, what happens here? It will be purified here. So in the lungs, the blood will be purified. So what are the alveoli which are here? What they will do is, they will completely purify this deoxygenated blood. So once the blood is deoxygenated, once the blood is oxygenated and once the blood is purified, okay, what it will do is, it will send that oxygenated blood. It will send the oxygenated blood to the heart, that is into the left auricle. So left auricle will have the oxygenated blood. So this is the pulmonary circuit, right? Why it is called as pulmonary circuit? Because it is taking place with the help of the lungs, because the lungs are making the purification, because it's the circuit between the heart and the lungs. So that's why we are calling it as the pulmonary circuit. In the pulmonary circuit, what happens? The deoxygenated blood from the right ventricle goes to the lungs, and the blood is, what happens to the blood? It is purified, it is oxygenated, and then it will come to the left auricle through the pulmonary veins. So these are the pulmonary veins. So these pulmonary veins will bring the blood back to the left auricle. So that is how this pulmonary circuit ends. So that is what pulmonary circuit is all about. Okay. Now what we'll see is systemic circulation. What we'll see is systemic circuit. Okay, you can call it as systemic circuit. Now whatever the blood which flows from here, right? So which flows from here, that is from the left ventricle, because the left auricle will pump the blood into left ventricle, then the blood now will be carried to the different parts of the body. Okay, so different parts of the body will take the oxygen and gives out the carbon dioxide. So these veins will carry that particular blood, okay, and then they take this blood to the where? To the, this is the right auricle, into the right auricle. So and the right auricle will pump the blood again into the left auricle. So this is the systemic circuit, because this systemic circuit, now this is called as the systemic aorta or aorta. So this is happening between the systemic aorta and the all parts of the body and the heart. So we are calling it as the systemic circuit. So that is how you can see the two different types of circulations in our body. That's the reason why, because the blood is coming to the heart twice for purification. Okay, so that's the reason why we are calling it as, our heart is called as the double circuit heart. But whereas as we have talked about the fish heart, it is completely different. It is not at all similar. Okay children, so this is the very important thing. So try to remember this one. Okay children, now we come to the topic of the blood pressure. We'll come to the topic of blood pressure. Now we have to go back to the previous class and we have to take few terms so that we can understand the blood pressure. Okay children, so now we'll talk about the blood pressure. Now we have already seen that if you have taken this as a heart, okay, and now this is the right ventricle, okay, this is the right atrium. So we have seen that the blood flows like this, okay, it comes out, okay, like this, and then enters into the arms. So especially now we are talking about the left arm here, where it goes to the other arm, and also the neck and the head. But whereas here it comes into the left arm. Okay, that means the pressure, whatever the pressure with which the ventricle is releasing the blood, okay, it is pumping the blood, that goes with a very good pressure in the systemic aorta, and then it comes into the left arm. That is the reason why usually the doctors will put when they want to check the BP. What is BP? Nothing but the blood pressure. So when they want to check the blood pressure, they will put the machine here, right? They will tie the things over here, and then they will check our blood pressure. So that is what's the reason behind that? Because the pressure here is absolutely accurate, because the heart pumps the blood from here. It comes here, right, with a very good pressure. It comes here, so the pressure will be accurate in the left arm, right, upper part of the left arm. So they'll put the machine, they will put the cloth here, and they will check the blood pressure. Okay, so now this blood pressure, when you check the blood pressure, so our blood pressure is basically 120 by 80. The normal blood pressure is 120 by 80. It's 120 by 80. So now what is this 120 by 80? Okay, that is what we are going to see now. Right children, our BP is checked by a machine, right? So that one is called as the sphygmomanometer. Okay, that particular apparatus is called as the sphygmomanometer. So as we have seen here, our blood pressure reading will be 120 by 80. So a normal blood pressure should be 120 by 80. Now what does this 120 by 80 indicate? What does this 120 by 80 indicate, right? So already we have seen that if the auricles of the ventricles contract, we are calling it as the systole, okay, and when they relax, we are calling it as the diastole. Okay, so remember these two words again, right? So when auricles or ventricles contract, we are calling it as systole, and when they relax, we are calling it as diastole. So systole and diastole are the two very important words, so that you can understand the blood pressure. So remember these two words for a while now. So now we are talking about 120 by 80. 120 by 80. Here 120. What is 120? It is the systolic pressure. It is called as the systolic pressure. What is systolic pressure? Now you can see that these are the ventricles, right? Ventricles, when they contract, there will be some pressure. If there is no pressure, the blood will not move forward, because the blood has to go like this, and then it has to come like this. So if there is no pressure, can the blood come out like this? No. When the ventricles contract, and these ventricles are a bit thicker and their space is a bit longer, like it is larger than the right ventricle. So when they compress, or when they compress, what happens is the blood will flow with a great pressure outside, and it comes into the blood vessel, that is systemic aorta. So that particular pressure is called as the systolic pressure. That is called as the systolic pressure. The force by which the blood is coming out of the ventricle into the systemic aorta, that pressure is called as the systolic pressure. And then when you come to the 80, this is called as the diastolic pressure. 80 is called as the diastolic pressure. Now what is diastolic pressure here? Diastolic pressure is nothing but, right, when the blood goes into different parts of the body, and now there is a time where the ventricles has to fill with the blood. Now coming to 80 is the diastolic pressure. What is diastolic pressure? That means here the arteries are, the systemic aorta is taking the blood very, very forcibly, and we are calling it as systolic pressure. So now after maybe some fraction of seconds of time, what happens is this particular blood which has gone to the each and every part of the body, and again has to come back and it has to fill the ventricles again, right? So, and at that time there will be delay. Okay, the pressure will not be such a great high. So this particular pressure with which the ventricles fill with the blood, because if they are only in the relaxed state, okay, when they are in the relaxed state, the blood can fill the ventricle. So that's why this pressure is a bit low here, and that pressure is actually called as the diastolic pressure. So compression is called as systole, relaxation is called as diastole. So one compression, one relaxation is the cardiac cycle. That is already we have learned. One contraction, one relaxation. So when contraction is high, the pressure is very high, and that's why we denote with the 120. And whereas when it come back to the heart again, so it will be a bit low, and that's why this is the diastolic pressure, that will be a bit low than the systolic pressure. So it will be 120 by 80. But whereas now you know this BP, that is 120 by 80, it will change in different persons. Like when people become old and the BP will change, right? So even BP also will change when there is a very good stress and strain, or when you're doing strenuous exercises and all, the BP will definitely vary at that time. And sometimes the reason for the very high BP is that, okay, now these are the arteries. These are the arteries, right? Arteries, you know, systemic aorta, arteries, and also these arteries, okay, now these are usually made up of the elastic, right? They are elastic in nature, they are muscular in nature, so they have the tendency to contract. They have tendency to contract. So when the ventricle pumps the blood, what happens is these particular, okay, arteries, they will expand, so that they can, what they can do is they can control the pressure. They can expand and the pressure will be normal. But whereas because of the deposition of fat, now because of the deposition of fat here, the fat will get deposited on the walls of the arteries, and because of the deposition of fat on the arteries, what happens is the arteries will no more expand. They will lose the tendency of expansion. So that's why now the space here has become narrow. So when the blood flows here, it goes with a high speed. If there is no fat deposits in the arteries, what happens is they will, now if the arteries are like this, they will expand so that they can balance the pressure. But now whereas here, now they will stay like this, and because of more fat, the passage will be narrow. So because of the passage narrow, the blood will flow with a high speed, and that's why we call this condition as the hypertension, or you can also call it as the high blood pressure. High blood pressure, and also you can call this as the hypertension. Okay, so this is about the blood pressure. Okay children, hope you have understood this topic, and tomorrow we'll meet with another topic, that is the coagulation of the blood. Okay children, until then, see you all. Take care. Have a nice day.